In this chapter about work and energy, we're going to be looking at types of energy. We have non-mechanical energy, such as chemical, atomic, sunlight. You can think about it, that's thermal energy. And then there is mechanical energy. So mechanical energy, there is kinetic energy. When we talked about kinetic friction versus static friction, kinetic meant motion. So this is the energy of motion. If an object is moving, it will have kinetic energy. And then there is potential energy. And there are actually two types of potential energy. One is due to gravity, and we call it PEG. And one is due to things like springs. When we stretch them or compress them, potential energy elastic. But regardless of what kind of potential energy it is, it's an energy that can potentially turn into another type of mechanical energy, which is kinetic. The formula for kinetic energy is mv squared over 2, meaning that it is always positive because, so for example, let's say my V is 2 meters per second and mass is 3 kilograms. What is the mechanical energy that is kinetic? We will take 3 times 2 squared over 2. So it's going to be 3 times 4 over 2, which is 6. And the unit for energy is joule. So 6 joules. But let's say it's the same object, but now it's moving south instead of north. Then V is technically negative 2 meters per second. Mass is still 3 kilograms. When I put my negative 2 into kinetic energy formula, which is mv squared over 2, I end up with 3 times negative 2 squared, which is also 4 over 2, so that's still 6 joules. So that is why kinetic energy is always positive, no matter where you move. And another thing that you need to notice is in the formula, since it's mv squared over 2, mass is important. The greater the mass, the more energy you have. But velocity is even more important because the speed in here is squared. A quick comparison. Let's say I have two objects and they're both moving at 5 meters per second, for example. 5 meters per second here and 5 meters per second for this one. Then kinetic energy for the first is going to be mass, which is 2. Velocity squared, 5 squared over 2, 25 joules. 4 kilograms times 25 over 2, so that is going to be actually 50 joules. Now let's compare this energy. I'm going to say this is kinetic energy 1 and then kinetic energy 2. Let's highlight it in green. If we compare these two energies, kinetic energy of the second object is twice the kinetic energy of the first one. Why is that? Because mass of the second was double the mass of the first. So just for practice, let's compare. I'm not going to give you any specific numbers, but let's say that mass 1 is triple of mass 2 and speed 1 equals speed 2. So two objects are moving at the same speed, but one of them is 3 times more massive. What is your guess? If it's mv squared over 2 for kinetic energy. In the first case, we're going to say 3 times mv squared over 2. But for the second one, it's just m. It's going to be, well, this is technically m2, and this will be m2 times v squared over 2. My first energy is triple of the second because the mass is triple. We can say that kinetic energy is directly proportional to mass. So if mass is 5 times greater than kinetic energy, let's say this is mass of object A, kinetic energy A, and this is 5 times mass B, then kinetic energy of A is going to be 5 times the kinetic energy of B. That's when mass is different. Now let's look at speed. Let's say that the first one is moving 3 meters per second and the other one is moving twice as fast, 6 meters per second. Now shall we compare our kinetic energies? This KEB is 4 times kinetic energy A. How could I figure it out from the formula though? Well, let's say M1V1 squared over 2 compared to M2V2 squared over 2, right? 2 and 2 doesn't matter. So we're comparing MV squared and mv squared for the other one. So the first one, I'm just going to use m because they had the same mass, but the first one had just v squared, and the second one was double. Look at how 2 goes inside the square. Then when you square the 2, it's going to be mv squared, but 4 is in front of it. If kinetic energy is directly proportional to mass, kinetic energy is also proportional to v squared, and that square is very, very important. Let's say VA is triple of VB, and mass A equals mass of B. Then how would I compare kinetic energy A to kinetic energy B? If I use the same mass, it's going to be M, and I replace VA with 3VB. So I'm going to keep the same color, M over 2, but then in brackets, I'm going to have 3 of VB. When I square the 3, it will be 9 in front. So it's going to be 9 mv squared over 2. So if my masses are the same, but the speed of one object is 3 times the speed of the other, then its kinetic energy is going to be not just 3 times greater, but 9 times greater. That is because velocity is squared in the formula for kinetic energy. So velocity, or speed for that matter, is more important than mass. You will square the factor. If it's 4 times greater, then it's going to be 16 times the kinetic energy that the object has.